Welcome, everyone. My name is Keller. I wear a couple different hats across open source. So you may have seen me in a couple different places, particularly Linux Foundation, the CNCF. I'm a member of the Technical Oversight Committee. In the OpenSSF, I'm a maintainer for a project we're going to talk about today called Zarf. But some of the, I think, underlying principles that I wanted to talk about before we lean into like, how can we do this? What's one way that this might be possible is to talk about transparency. I think of transparency less about the maybe a definitive definition of what is trying to solve, but more so like the act. And that's really what I wanted to cover today is really like the act of how can we make software, how can we make open source projects and their deliverables more transparent in such a way that they can convey trust. And I think of trust as a very subjective, ominous target, right? It's really hard to do. It's different from person to person, organization to organization. And so what do we do? What can we do in open source? What kind of different strategies might we use to get there? And so one of the perspectives that I think is most relevant, particularly to open source and the ecosystem, is the producer perspective, right? If you are a maintainer for a project, you typically are releasing your software in a variety of ways. Maybe you're packaging it up as container images. You need a way to facilitate configuration around orchestration. So you might have Helm charts, manifests, customization, manifests, etc. Any of that configuration to do so. You might then have an inventory of what your software is comprised of so that people can look at it and understand. You might have vulnerability context, XYZ, right? You're going to assign your software, you're going to do a test to how it was built and your pipelines. And so all of this is this kind of complex web. There's a lot of different pieces at play, and we do our best. We do our best to kind of create these things so people can understand them, so they can get a level of confidence around what this software is, what's it comprised of, and how it was built. And that's great. These things all serve fundamental purposes. We tend to keep adding more and more, and that's perfectly fine. But they all serve a distinct purpose. And how can we start to collect them in such a way that we can, create some confidence around that whole web? How can we make that available to the producers, the maintainers, so they understand why an additional step in their pipeline could be valuable? And so when you do all those things, that's wonderful. You usually document, hey, I've signed to my software. Here's how you can verify the signature. Hey, here's the SBOMs. Here's how you can look at them and find them, et cetera, et cetera. And our connected systems and the open source ecosystem, our GitHub projects, they are very well connected, right? They serve a, kind of distinct purpose. You can access the internet, you can access them, and you can access everything you need to use them. That's great. The registries are readily available. All of our signatures, you can pull them as you need, and all the services which you need to, maybe perform a signature verification and the key materials involved with that. It's all accessible, as well as the tooling, right? The tooling is very accessible in GitHub Actions, for instance. Hey, I just add a step to my pipeline. Maybe there's an action provider that allows me to install some tools so I have it. And we pin those things in such a way that updating them is relatively trivial. A release comes out today, an hour from now, renovate, dependabot, something or other is telling me that there's an update, and I accept and merge and move on. And so it feels very easy. From the verification standpoint, you just pull what you need, access what you need, and perform verification. Something that I think is very relevant to the domain that I work in particular, which is kind of the full opposite side of the spectrum. I work with like air-gapped environments, and those start to show a variety of constraints around what assumptions did you make around your verification strategies. Things kind of start to break down very fast when you think about the producer world and that perspective of producing software, maintainers for software, and the constraints with which somebody in an actual environment may have to perform verification, but may not have everything they need, right? In air-gapped environments, this is very obvious. If you want to deploy a piece of software and you have the Helm chart and you're looking at it and you think I need all these images. You got the Helm chart, you got the images, you do so how you will. You move it to this air-gapped environment that has no connectivity elsewhere. So you just have the artifacts. And then you say, hey, run this piece of software. And the Helm install comes back and says, hey, we could not complete it, Helm install failed. Whatever the error is with which you debug your Kubernetes cluster and see, oh, I missed an image. Well, that's a very cognitive burden type life cycle if you think about. Now I need to go back out to the connected side, grab another thing, come back, test back. Confidence levels, begin to degrade at that point in time. The same thing applies to metadata, signatures, key material, SBOMs, etc. Like all of these things are very easy in a connected world to have access to, but are they as easy for your consumers, right? And I like to use the air-gapped as a very extreme case, but it doesn't have to be an air-gapped environment, right? It might be an enterprise network. What are their policies for pulling in external software from the internet? And it may just be proxies involved. Are those proxies built in such a way that they pull the referenceable metadata in some way, shape, or form? Maybe the answer is yes, and maybe this isn't a big of a problem. Or likely the answer is no. And so we really want to think about when an exchange or a boundary occurs and you pull a piece of software into an environment, is everything you need there from a consumer perspective still there in order to perform verification? And typically we see that it's one boundary, but it may not always be one boundary. It may be an artifact who has been pulled through many different proxies, many different registries in order to get to its end environment where it's actually going to run. And so I'm going to try to get through slides and such so that we can actually get to the fun part of the demo. But the kind of use case study, if you will, this is not the only one. This is not the only strategy for accomplishing these things. But the one that I think is very, relevant to me, relevant to the ecosystem of the consumers of Zarf that we've been working with and trying to build has always been be very intentional about bringing this metadata with you. If you can declare it in a declarative definition and you can package it all up into something that's portable, it is very intentional. You have what you need because you declared that it needs to be there. And if you couldn't find it when you were doing the packaging, that's going to fail. So it's very obvious when you are missing something and trying to get to that life cycle of ensuring you have everything you need. And so the argument that we're kind of shooting for with our use case is that, supply chain security should really travel with the software. And we should be very intentional about that. And in such a way that no matter where the artifact goes, the supply chain metadata goes with it. And so this strategy is one. We may be other strategies. Maybe we go back to standards. Maybe we go back to technologies and tooling that can solve this for us. Is a very great example of a tool that is, I think, very front and center of trying to acknowledge that, like, hey, we're storing information, software, metadata, other data in OCI registries. Let's make sure everything that refers to those artifacts also is pulled in when we're pulling them in such a way that if you were to use kind of like Aura's backup tooling, it would pull all that stuff, tarball it up, and then if you wanted to then rehydrate it, it has everything there. And those are the same models that we're trying to apply with Zarf. We want to create this portable unit that has everything from your artifacts down to your SBOMs and all of the rest of the provenance in such a way that it's portable. And so if you take that evidence that's in the portable element, you can not only run the software, you can have everything you need to verify the software before you run it. Very important distinction. I don't want to run software and then later ask, do I trust this thing? I want to establish that. And so you provide these processes of, here's the software and its static element and its portable element. Can I inspect this and look at it and reason about how well I trust this thing? And if I have a lot of, transient supply chain metadata, there's a lot of benefits to that element of trust that you can build, that confidence that you can build. You can put all of that information through policy, whether it's something active enforcement through, your runtime kind of environment. It could be in CI, or it could just be, some ad hoc. I want to re-inspect this thing and look for some specific piece of metadata. What tooling would I use? And so we get to the point where we have these expected outcomes. And so enter Zarf. Zarf is an OpenSSF Sandbox project. And really, our origin story starts with Zarf being a portability solution. How do we get cloud-native applications from the internet or even your environment if you have your own registries and Git servers, etc.? How do we get all that packaged up into a portable unit so that we can then deploy it anywhere, regardless of connectivity? It has all of its dependencies. That was the core use case, and really still is the core use case for Zarf. If you want to have something that is deployable to air-gapped Kubernetes environments as the extreme, but we see it in connected clouds all the time, then what do? Zarf is one opinionation on this. We've been doing Kubernetes. The ecosystem, CNCF, Linux Foundation, the landscape of open source in general, we have been doing air-gapped Kubernetes for a long time. It was always built in to kind of some of the underlying assumptions, right? What do you need to do air-gapped Kubernetes and to deploy an application? You need some fundamental elements of your environment. You need a registry to push images to and things like that. But really, at the end of the day, you can pull images and Docker save them so you have their tarballs. You can pull your Helm charts, pull any other relevant metadata, and archive that and ship it. Zarf is an opinionation on that so that we can take all those activities and maybe some of the areas that are really rough around configuration management and make it as easy as 2 commands: Zarf package create and Zarf package deploy. So kind of as a quick precursor, again, the dependencies here are you have a YAML manifest that I'm going to show next, and you take all of your cloud native application information, metadata, container images, etc., and you run Zarf package create, and it creates a Zarf package. You typically do that in an environment where you have connectivity to all those resources, or otherwise you wouldn't be able to package them. But then once you have that portable unit, that portable Zarf package, you can take it anywhere. And so hopefully this is semi-readable for something like Argo CD, right? That we saw earlier in the keynotes. I want to deploy Argo CD to any air-gapped environment. I would, create a static manifest. I would say, here's some metadata around a versioned portable unit for Argo CD and its version. I can give it additional configuration. And at this point in time, you're taking the upstream, you can see here, Argo CD Helm chart, and then overlaying it with additional constraints, right? We always try to reach for, hey, we should be building all of our orchestration and our releasables at the first point upstream as hardened as we can, right? And I think for the most part, we do that to the best of our ability, but we also don't want to hamper the UX of adoption, right? When somebody wants to just test something out and get a feel of what is this thing? How does it work? What does it do? Adoption really can be borderline. Could I get this up and running quickly? Quick enough to actually retain people's, interest, while at the same time ensuring that we don't misconfigure something or do something that's going to make any of their environments vulnerable. And so if we add one layer of abstraction to that, which is packaging this thing up, when we're actually pushing it to production environments, we can overlay, hey, I'm gonna harden this thing at this point in time and make it so that this thing is really locked down and ready to use. I'm only going to expose configuration that should be, dynamic. And for other things, I'm going to explicitly not list them as areas that we can modify. I don't want a user to be able to flip some switch for, plain text secrets transmission or things like that. I want to make that very hard. And if they need to change that for some reason, it's very explicit. And it requires extra actions. And so we have Helm charts. You can see that here. We're just pulling straight from upstream, maintaining that upstream visibility. You know where this thing came from. Even if you took this artifact over to an environment that it had to jump through 10 different proxies and registries, you can still point back to where was the source origin for this artifact. You package up your container images, package up your signatures and attestations. You can kind of see that here. Additionally, documentation. And this is all representative of one component, right? If your application has dependencies, maybe you need to deploy a database, then you can add those as additional components and split them out in a way that now you can have a little bit of a delineation between here's a dependency for my application and its supply chain metadata, and here's my application and its supply chain metadata and things like that. And so on our connected side, you can see I'm connected to Wi-Fi right now. If we come in here, we'll clear that part out, and I am in the directory where we have this zarf.yaml manifest as well as all of its other supporting elements. I can do a zarf package create with a little feature flag here for this package. And what it's doing at this point in time, right, is pulling those from the internet. I'm going to pull the Helm chart that we have referenced in the manifest, pull the images, the signatures, attestations, pull them in there. You can see down here, we're also creating SBOMs. And so again, the supply chain metadata aspect of this, make this very portable. Also make it really easy. There's a lot of people who have been adopters for Zarf for years now. Zarf really got started around the 2021 timeframe. And they have been using Zarf ever since. They've used it for that portability aspect of deployments. And we started adding features that make some more of the supply chain aspects of this easier and maybe almost invisible, right? People have came to us and said, hey, I really need a good mechanism for getting SBOMs into my package. And it's been enlightening to say, maybe you missed the logs down here of creating SBOMs just because you've ran this command a billion times. But your SBOMs are actually already there. And so you can go back to those artifacts you've created years ago and find your SBOMs for them and reason about them and put them through systems that might be able to kind of enhance your awareness around them. So I've created this Zarf package. It has everything I needed inside of it. We can do additional things with this package. We can sign the package as a whole. All right. I've created a platform in my Zarf package in different examples, a whole platform from 10 different microservices and databases and all these other dependencies, and put that all in one Zarf package to make it highly portable. I've spent the time and fortitude to go through those artifacts and make sure that there's nothing in there that I'm concerned about and reasoned about through their software supply chain lifecycle. I can sign that in such a way that now that whole package is signed. One signature that's going to rule like all of the artifacts within it. There are implications there for sure, but you can do that activity in such a way where once the internet is removed, and we'll hop off Wi-Fi here, that we can still reason about things, right? And so one thing that you'll see here is we've got a new Zarf package, Argo CD tarball. And actually, before we even go as far as removing the Wi-Fi here, I'll jump back on just for a second. And to reason about that, this artifact, this portable unit, is meant to be highly portable, right? What kind of standards do we typically use for kind of transferring these things, making them they're easily available? Is OCI. And so you've just now pulled all these artifacts. Maybe they all came from OCI registries. You want to make this consumable. Let's put our maintainer hats on for a second. Here's a hardened version of the of our project. It also has all the images and the SBOMs. And so even if some compromise were to happen later on, that artifact is already kind of established in its immutable state, if you will. And we can push these things to an OCI registry. So if we do a Zarf package publish, for instance, I could take that Argo CD package and I could push the whole of that thing up to something like GHCR, my local registry, my internal registry. And now somebody who needs this artifact, they don't need to go and rebuild it. They can, and they should get a reproducible output of the same thing. But let's say you are making this available to your consumers. If any of you are maintainers for projects, please come find me if this is of interest to you. I'd love to help you with that life cycle. But now it's published. You have this one portable unit of all those things that I already showed in the manifest ready to deploy. Now we can go offline. And we can do some fun stuff here, right? And so I showed we have a Argo CD package. I have not signed that yet. I can at any point in time, and it's basically going to augment that package with the signature and produce a signed version of that package. But our Zarf init package here, which is kind of some baseline infrastructure that you need to initialize your clusters with Zarf, particularly if you look here, you can see my Kubernetes cluster has basically a vanilla kube system, a storage class, and then Zarf infrastructure. I can go into that more later, but that's kind of not the focus for today. But the Zarf init package is that Zarf infrastructure that you see here, and we can totally offline. We have no connectivity to any of the internet or things like that. I don't have anything cached for doing signatures outside of what is already here. I can do a verify on the Zarf init package, and because we've built Zarf in such a way that we can do offline verification, no matter where this artifact goes. Here we're doing a keyless signed identity and issuer. I can go ahead and run that, and what you will see is we're going to put it through our verification workflow, right? We're going to verify all the checksums and then verify the signature that was within that package, and all of that is complete. Underlying details here of how we checksum every file, and we checksum the checksum file, and we have an aggregate checksum of the checksum file. So in such a way that that tarball or that OCI reference can't be tampered with in any way. These are all things that I'm kind of glossing over because there's lots of things that I could cover. But we can perform these verification workflows. If at any point in time I want to then say, hey, I've got this Kubernetes cluster that we saw. I want to deploy my Argo package, but I don't trust it yet. What's inside it? Somebody just handed me this tarball, and I see this still today, where people have burned Zarf packages to CDs because it's still a transfer mechanism that's in use, and taken it to an environment and said, okay, wonderful, you're telling me that deploying Argo CD is as easy as Zarf package deploy. But before I do that, like, what's in here? Is there anything in here I should be concerned about? How can I look at and reason about the signatures and things like that? And we show the signature. Zarf package inspect is really meant to be our kind of, safe operation for let's look at the package. And we're trying to continually expand the surface area here. So if I look at the Argo CD package, we got to do inspect here. And so if nothing else, I want to look at the definition. What is the manifest that is comprised, this package is comprised of? We can go back to this, and you're going to see the very same thing that you saw in the manifest earlier. If it's been mutated in any way, those changes are reflected here. You can do a lot of composable actions in Zarf. And so before you run anything, you also get a bunch of additional data, things in particular like this aggregate checksum. If you really want to dive into deep to the details around it, the architecture, versioning that you saw, but also like the build environment. When was this built? For what architecture? What things are of interest to me? Is this signed? Is this a signed package? What kind of provenance files are available for me to look at? This is all information that we deem as like valuable to users in such a way where if this is YAML, we can easily take this and put this through policy, right? So before you've ever executed anything, before you've ever loaded this package into memory in such a way where there might be something that you want to reason about, before you do that, you can put your package through a variety of different policies and say, hey, I do not allow unsigned packages to be deployed. Full stop. That's okay. We reason about that. We put policy in there, and we move forward. You can look for various different things, right? Because Zarf is meant to be not solely a Kubernetes tool. You can also deploy bare metal. We've seen operating systems be deployed with Zarf packages themselves. because then we can start to transfer operating systems as OCI artifacts. All of this comes into play when we want to say, what's in here, what is it comprised of, and why is this meaningful to me? We can also do other things, right? We can reason about something such as, if I've got configuration in here, my Argo CD Helm chart, and I want to look at my manifests, I can get a full picture of how is this templated chart going to be produced. Lots of information in here, obviously, because we're deploying Argo CD. So you might be looking for different things, right? All of those policies you probably put into place in your runtime environment, totally applicable. Please continue to use them. But if you ever want to shift left of the action of having deployed something, then you can reason about this in your pipelines. You can reason about this at deploy time. You can reason about this however you will, based upon the systems that you have, whether you're using GitOps or other reconciliation workflows. Zarf natively works with Flux and Argo. And so when you think about air-gapped environments and Argo CD and Flux, typically you're like, oh no, like where's the Git server? What did I do here? And we handle a lot of that underlying infrastructure where you can just pull your Git source of truth into the Zarf package and deploy it in an internal Git server. And now you have the ability to still do GitOps in the same way you do on connected systems, but on disconnected systems. And so with that, again, we reason about it however we will. We verify signatures. We look at other things. We can look at values files and a variety of other information. We can look at SBOMs. And that's particularly one that we see people do. And so you see it's just written out. And Argo CD directory here, and it contains HTML and JSON for particularly the images that are in this. If there were other artifacts, we get the SBOMs for those as well. And so we're just trying to figure out how else can we expose information in ways that's valuable. We used SBOMs in a fashion where typically you would, use this method to get your SBOMs and then put those through something like Gripe or Trivy or however else you want to scan your SBOMs for vulnerabilities. As of the latest release of Gripe, you now can just scan Zarf packages natively with the Zarf scan target, which makes this really easy and fun. But now that we've reasoned about it and said, hey, I trust this thing, we can do the fun part of Zarf package deploy and the Argo CD package. Again, I'm not on the internet. I have a local Kubernetes cluster that you've seen, and I can do that. Again, before you do anything, do you actually want to deploy this? And here's what it's comprised of. You can skip this if you want, but we just want to highlight things. If there's a script that needs to execute in order to get some environmental configuration, want you to be very aware that that is going to occur as part of this process. And are you okay with all of these things? So you say yes. For air-gapped environments, we push all the images into an internal registry. If we have Git repos, we push those into the Git server. Then we would perform the Helm chart install. And what I think is really important about all of Zarf is that you're never locked into Zarf if you're using it, right? You deploy Argo CD with Zarf today, and you can come in and use Helm ls, -a, and you can see that, hey, I have Argo CD deployed with Zarf, but I can still stop using Zarf and move on using Helm and continue to upgrade and perform the lifecycle. We never want to lock you into using a tool. And so that's one of the things that's really important to us. But then the fun comes with like, okay, if I want to Zarf connect, Argo CD, I can open up. Argo CD has a direct connect option from wherever that is running. We have these labels that you can add to your services in such a way that makes it really easy to just get a direct connection. A lot of air-gapped environments don't have an ingress service, or maybe they haven't configured one yet. And so you have these other optionality, like how else can you connect? And so we've deployed Argo CD and all of that. And I think really, when we drive back to, do we trust this thing and to what degree? We're just trying to signify that we want to do this all left of the deployment timeline. And when we even think about the producer maintainer hat perspective, what feedback loops can we get? So one of the feedback loops that we typically use is, how can we mock air-gapped environments? And, now we have a lot of tooling and pipeline options that make this easier to do, where we can just kind of like turn off all external connectivity. But we can do a deployment with Zarf in such a way that Zarf isn't going to allow you to, pull online sourced images into your environment, run that, continue to iterate and iterate until you have a successful deployment before it actually ever goes to a production environment and you find out something is missing. And so I think what this really represents is you have to acknowledge that the consumer environment may not live by the same connected constraints that we're used to out in the open source ecosystem. So yeah, going back to kind of the transparency aspect of this, we covered everything that gets bundled in. Now it's verifiable, it's auditable, we can look at everything that's in here. We can augment the information in various different ways with documentation, and you can inspect and repeat those checks later, right? That signature verification that we performed on the Zarf init package that's signed with a keyless identity, it can go, we can play hot potato with it, and I could give it to somebody else can pull it down, push it to their registry, they can pull it down, pull it to their registry, et cetera, et cetera. At the end of the day, 100 registries later, that artifact still is a signed entity, still has everything you need to perform offline verification, given the constraints of some of the most extreme environments. And so it creates this portable unit of trust. And we believe this is really, really relevant. We're not done. I'm going to kind of mention this in a minute. But secure defaults still matter, right? And we want to find ways to look at and reason about not only the software and its configuration and things we typically look for, things we typically enforce with policy, but we want to find other ways to augment the software. How can we create more secure deliverables that aren't, I would say, as vulnerable to compromises that change, something around the mutability of tags? If we have a high level of trust and confidence around, a point in time where software is released, and then we build this portable unit around it, now we have a high level of trust around everything from checksums all the way down to Helm charts and images. And if your connected environments rely on upstream Helm chart references and upstream image references, there can be a lot of, reason for concern around, something like one of those changing and the mutability of that. Or there could be a lot of concern around even the, what looks to be a relevant release of something, and what happens when those things are compromised in some way, or what happens when those things are just not available. If you're reliant upon images pulled from a registry and that registry is not available for some period of time, right at the time with which you need it, you're going to have problems, and Zarf is building in some redundancy. So we get to early enforcement when it's available. Kind of as I mentioned, we want to make these feedback loops available for these constrained verification workflows, make overrides understandable, right? I can look at the values files for a package and not only reason about like what were the defaults of my Helm chart and how that's cascading into those manifests I showed earlier, but also the overrides or the additional layers of configuration that I'm putting on top of that as an additional layer or additional abstraction. And so we're continually moving forward, kind of in alignment with the OpenSSF. We want to make open source software more secure. And so as different projects start to integrate Zarf as a portable unit, Zarf as a release artifact, this is something we highly encourage, and we want to work with projects on that. But we also want to continue to expand the lifecycle. Can we verify every artifact as it's coming into the package? Not something that we do today, to be totally honest, but it is something that we could do. And that's what we're working forward. And that's what we're going to implement. And so what all this unlocks is you don't need as much for network reachability. The bespoke verification work at every single handoff becomes much less insurmountable. Interoperability between producers and consumers. They have this understood, portable handoff and a practical constraint. And I kind of breeze over takeaways here. Evidence needs to be part of the release. So if we're not producing SBOMs for the upstream thing, these are reasons for us to continue to try to push for their adoption. Verification must survive that handoff as we move from producer to consumer. Otherwise, verification is inherently useless. And transparent packages make this trust highly portable. And with that, thank you for your time.